Good morning, everyone.
Good morning.
Are we
Good
good to
morning,
start?
everyone.
Okay, let's get started. As a part of product and system testing practice, we have been helping our customers to implement automated impact analysis for unattended continuous testing model, which is actually based on analytics and machine learning. Today, myself and Vivek, we will actually talk talk about why do we need this automated impact analysis and how we actually uh, build this automated impact analysis and what kind of benefits that we will actually derive for our customers to move their quality needle to next level. And we will also today we will actually share a couple of recipes in which you can actually go back and try out, in your own project and start your applying analytics and machine learning journey from Monday itself, right? So with that, we'll get started. So typically for any quality organization, right? So every change that are coming to the system, whether it is be changes to the requirement or it's a changes to the code line, right? So each change actually brings in its sort of risk, right? So it's very important for us to really identify what kind of risk each of those changes bring in and kind of come up with the mitigation plan of right having a good testing around that area to de-risk the risk that is coming in, right? So the World Quality Report also suggests that 60% of our customers are actually trying to trying to apply automation on the DevOps pipeline. They are seeing challenges into this, right? So, as I mentioned, right, the changes that are coming into the system is a risk, right? So, anytime which is actually coming to this, right, we will actually go through the kind of a risk analysis, right? So, and kind of come up with a test cases, what test that I need to run it, right? So it's while we do this impact analysis, we will have to go through a lot of historical data and various data sources, like what is changing in the requirement, what is changing in the code, what is the impact of the changes, right? What is the collateral impact? What other things that we need to look at it? What changes that, what test cases that have failed recently, and what is the feedback that we are actually getting it from the field, and everything we need to consider to come up with a test plan, right? It's very difficult to consume a huge amount of data, which is from the various repository that we have. And also, it's very important for us to maintain the time, right? So in the continuous integration pipeline, the quicker feedback is really important, right? So for any organization, identifying the bad fix that are getting into the code line very early, as soon as possible, they introduce and kind of identify them and eliminate them to maintain the good code health, right? So the time is very important. So manually performing this impact analysis is actually a kind of troublesome, and it's actually reduce the our quicker delivery to the market, right? So with this challenge, right? So how Impacto, so we call this automated impact analysis model as Impacto, is actually going to help this continuous automated impact analysis. So let's consider this, right? So we have a build which is actually a number of changes that are coming into the build. The model actually consists of three major parts. So the first one is for the first model, actually identify the changed and impacted areas. And the second model, which is actually the riskier code prediction model, which actually identifies the what files or what is a hotspot. And the third model, which is actually test box, the test selection and prioritization model, which actually takes input from the rest of the module. Along with that, it actually having a 40 plus different well-tested test box patterns. We will actually discuss these patterns in detail. It considers the various factors and actually come up with the dynamic test plan, right? So the in the continuous integration pipeline, so might want to run, say, static. The After static code analysis runs, you might want to run the build verification test, and then after that you would want to say nightly sanity and different kind of test that you need to run, right? So it comes up with the recommendation on the dynamic test plan based on the request that you put in. And it has got the REST API interface in which you can actually easily integrate it with any of your CI/CD pipelines. Hence, the testing happens unattended seamlessly, right? So if you have a nightly build that are coming in, before you come to office, you will see the results of those test cases that are being impacted to the system, right? Let's look at what is this test works and how the test selection and prioritization modules being built, right? So, which actually factors the various data from multiple repositories, starting from your test execution records, different records, requirements, and the product management data. It actually brings the data together by understanding the link between this data coming from the silo repositories. It extracts the pattern from the historical data. These patterns could be positive or negative patterns. Use these patterns as a kind of predictors to come up with the recommendations on what test really matters, right? So um, uh, this also considers various other factors, right? So let's say a situation like you are an architect in the absence of system like TestWorks. How would you go about finding the right test cases for your current build, right? So you would really use your historical experience working in this project, your intuitive judgments, set up rules of thumbs, and the best practices. And you might have seen certain incidences, right? Whenever I see this test is failing, there used to be another set of test cases that are failing together, right? So you might want to pull out those test cases also, right? And kind of some of the common sense, right? So if I have a fix that are being getting into this build, I would want to run the test cases that have found this that defect, right? So we will use set of heuristics. These are kind of mental models that say. So we have a framework which actually kind of analyze the patterns that are actually coming from these SMEs that they're currently using it. We will kind of sit with them, probe set of questions to understand these patterns. We will model these patterns so that we will actually retain the knowledge that has been there in the system, right? So we see the SME's knowledge is the biggest assets to the team, and that cannot be replaced with any of the algorithm and so on. So we will try to mimic those mental models that are being used by the SMEs. That's number one. And also we will look at the patterns from the data, the historical patterns, how things are working, what is not working, what are the correlations, associations. Based on that, we will come up with the patterns. We will model those patterns as well. And then, as a practice team, we have been into this for almost 4.5 years now, right? We have been part of various mining repository challenges, the conferences, and experience working with various customers, and things that are working, the rules, the heuristics that are working for other customers. We will see the applicability of those heuristics also for this particular data set, because the data is going to be different for a different project. We will actually look at the data quality, availability, accessibility, and sufficiency. Based on these factors, if it is applicable, we will actually pull in those heuristics also and model. And the last one is the feedback, right? So let's say you have come up with recommendations that it is being given to the CI/CD pipeline, the tests are being executed, the results are of the recommendations also being taken into account to alter your recommendations as a self-learning system, right? So these are the various factors or the heuristics that we will actually consider to come up with the testworks model. Okay, so I would like to talk about a couple of recipes, like which is something that you can go back and start implementing in your day to day when you go back to your office on Monday, right? So I will talk about two recipes. The first recipe is something which you can simply implement without with without having a lot of complex algorithm with simple statistical formula itself, right? So if you see this, this chart actually says the test execution. It is built based on the test execution records. So the x-axis, the test cases. Let's say this test case one, wherever we have the green bars, which actually states the number of times the test case is being executed, and then the red bars are the number of times that are failed, the test case is being failed, right? And the dots is the test failure frequency, which is being calculated with a simple formula like number of times got executed divided by the number of times failed into 100. Okay, so this itself gives you a lot of insights and how we can actually do better test optimization and prioritization. Look at this, the test cases that are having the zero TFR, right? What this means, these test cases are being executed and it's never failed, right? Look at these test cases T15 and T16 that have been executed almost 100 times that it's never failed, right? So I can really think like, should I really have to run this test cases when it's not at all giving me a failure, right? A good test is something that which fails more often, right? So in this case, I can actually reduce the cadence, or even I can go back and really see that is this test case really worth refactoring, right? So can I retire these test cases? All these discussions that I can have it on these test cases. However, if you look at, there are some test cases having the huge, I mean, very good test failure frequency rate. And if you see this, test 9 is been failing always, right? So why don't I run it more often, right? So these kind of decisions is something that I can actually make it. So I can increase the cadence of the test cases that are having the higher TFR, and reduce the cadence of the test cases which are having a lower things. And even I want to go for refactoring it. This is very quick thing that you can simply implement it even your day-to-day life. Right, so let's look at an application of machine learning algorithm, how we can actually start implementing this. So this is again test execution records, which is represented, the test cases are in the y-axis, and for each test cases, right? So for a given build, like the build one, there are a number of tests. I mean, there are, let's say, 22 test cases been executed, and this red dot denotes the failures of those test executions, right? So in this build one, there are 4 test cases failed, and build two, either it's not executed or it's not been failed. And similarly, there are observations available for about build 19. As if you look at it, we are not finding any patterns out of it, right? So I just changed to a different view, right? You see this, these two green ones, right? So these are actually failing always together. You see this pattern, right? This is something is hidden, right? So just like your code components are linked and associated, the test case is also associated and linked, which is very difficult to find out with easy methods. So that's where the algorithms like machine learning actually helps us to find out those associations. So this is a very good example of finding association of test cases. In this case, you see this test cases. Whenever T7 fails, T5 also fails, right? And the next one is like whenever Tn actually fails, we see that T18 and T16 also fails. Similarly, we have another set, right? So if you look at it, I get 3 associated failure sets. So these test cases are kind of 2 plus 4 plus, so 3 plus 4 plus 2 is 9, right? So this 9 test cases are representative, I mean, 3 different representative groups, right? It's so how I can actually use this information is that, okay, I can actually pick one test cases from each group, which I can actually quickly run it and get the feedback from for a build, right? So based on the results, let's say I've taken T13 and then executed in the build verification test. If it's failing, so I can actually start executing the remaining test cases as well. So that way, with the quicker number of test executions, I should get the quicker feedback where we are having identified the test failures much earlier, right? So each and every test execution is a cost to the company, right? So we have to really think how we can actually select and prioritize our test cases so that we get the better return on investment, and our objective of identifying the bad fixes as soon as possible in the code line, right? So with that, okay. So this is something that you can go back and start learning an algorithm called a priori, right? A priori is an association rule mining algorithm, which is going to identify from these observation and test from test execution records. Typically, we will use the test ID, test case build number. If it's not build number is not available, you can actually use the timeline as a build, and then the test execution. These are the three fields that we will actually feed into this algorithm, which will actually going to give you the associated test groups along with the how many occurrences that observations are made, and also the probability of when T13 is failing, probability of the T15 and the remaining test cases failed, right? So with that, you can actually build another little business knowledge or logic on top of that, and you can actually feedback and implement to your CI/CD pipeline. So this is something that you can also try out in your day-to-day life. So we did talk. This will actually kind of help you to start your journey of applying analytics and machine learning in your day-to-day life. Okay. So just looked at it like the test work model to come up with the test selection and prioritization recommendations. I would request Vivek to just cover the riskier file prediction components and henceforth. Vivek, over
Uh,
to you.
thanks, Jagdeesh. Good morning, everyone. I will be taking it further and covering the riskier files and the component prediction model. So there are a set of hidden code quality patterns that we derive from the incoming changes to the repository. Uh, I will walk you through in deep about all such features. uh, we call it Impacto. So Impacto factors different sources like the source code repository, the code review, the project management data, and all sort of metadata that is available around the repositories. And it tries to extract all the different features like change, temporal, code quality, churn, people, all such factors it tries to extract. And there are more than 50 plus such features which are being derived around each and every component or file, whatever level we like to see. So let's say for any incoming changes or any component which is a part of our source code, there will be all such features which are available to us. Machine learning model will be trained based on the historical patterns and the historical data that's available around all of this, and we try to come up with a prediction for riskier files and components. So this riskier files and components are nothing but they can be considered as a hotspots where there are a lot of activities happening, or which have been identified by our model as to be riskier as compared to the others. So it's nothing but kind of a high components with high probability of carrying some risk, like might be some bugs or some defects which can be taken care of before going to the production timelines, or that can help us to provide some actionable plan which can to just sanitize or just to clean up before moving further. So I would like to share some very good actionable insights that we have found earlier from our previous executions. 63% of the commits submitted after 3 p.m. on Friday turn out to be defective. Then the other one is like 45% of the commits on happen on less than 10% of the source code files. So here we can get an idea, like there are certain set of files in all the repositories which are very feature heavy. So there might be some underlying risk where they need to be made more modular, or there is some refactorization that needs to be done at those levels. So all these are some basic insights which can help you to have some internal brainstorming for increasing the efficiency, and this can help you to improve your time to deliver and optimize your overall delivery strategy as well. Yeah, we can move further, where I will dive you through. I will give you a deep dive about some of the factors or features that are a part of it. Uh, I will start with the change metrics. So, in change metrics, we look at the changes that are happening to the repository. Uh, Parameters like number of changes that are happening to the file, and like if a component is getting changed more frequently, then that is something that can avoid being more risky as compared to high activity happening to that particular component. Similarly, like number of consecutive changes, like if a file is getting changed consecutively, like let's say 3 to 4 times in a week, in permissions, or in current history, then those type of concurrent changes can introduce some risk. Similarly, we can look at the churn factors, like some of the files, like we already saw earlier, like 10 percentage of the files contribute to more than 40 percentage of the changes. So in such scenarios, there will be some feature heavy files which will be having very high churn happening. So the churn total for these files will be quite high. So such type of high churn volumes for a particular set of components can introduce huge amount of risk to the repository. Moving on, we can look at the temporal factors. Temporal factors play a major role when we look at from the delivery point of view. Like all the changes which are made very close to the delivery timelines, or very close to the schedule for production, can be very high risky changes, which can impact the overall quality of the delivery. Similarly, we can look at the people factors, like too many cooks spoil the broth. So, like if there are a lot of people, like let's say 5 to 6 different developers, contributors who are contributing to a particular set of file components,
Vivek,
then
Vivek,
that might introduce.
Vivek, sorry to interrupt you. We are hearing a lot of disturbance from your side. So can I take it further? And maybe you can now switch off your video and see if that helps. Okay, so yeah. Okay, while Vivek is coming back, so I would like to cover the various other factors that we do consider. So basically, these factors are something like we will numerical value that we will actually derive out of the data commit records and other records. Okay, so Vivek did cover the temporal aspects, so that is very important. Any change that are coming into the system very late in the cycle is actually risk to the schedule as well as to the quality. So that brings in sort of risk. So we will actually measure that with the first change cluster, time lost cluster, and so on. And we will also derive a quality index that are actually coming from various code quality factors that are coming from the static code analysis data, example like cyclomatic complexity and comment density and so on, right? And code smells are also very good indicator for the risk predictions, right? So that also we will consider them. Again, this is coming from your static code analysis data. Churn is another thing which very important to really see assess the risk. So basically, like in a given time, right? So how many changes that are being churn that has happened to a file, and when is the maximum number of churn that are happening to a cluster? All these factors that has been derived, and as Vivek mentioned, the people factor is the most important factors, right? So we will see that like when you have too many people coming in, making changes the risk to the file. And also the different varieties of people, right? When people coming for the first time is having the higher risk than a person who's actually very comfortable making changes. He has worked with this file for multiple times, is actually the risk is having lesser time. And even a cluster of changes, right? When that itself is a risk. When too many people are actually contributing for the cluster of changes, that itself brings more even risk here, right? So we will actually consider all these factors as an risk indicators. These factors actually act as an input variables to predict a variable called is failure risk here. So is file risk here is something that we will actually identify based on the labeling. So the labeling is something which we will do it with based on the NLP to determine each of the changes is actually to fix a defect, or it's actually for fixing or enhancing a feature or creating a new feature. So if I'm making a change to a file to fix a defect, that means I can actually assume that file is defective until I make that change, right? With this analogy, we label it, and then we will apply a set of classifier to come up with the probability. Based on the probability, we will kind of identify a file is riskier, high risk, more low risk, or medium risk file. Um, so with that, we will actually talk about the how we actually implement this kind of models for our customers. We will typically start with the data collection. Do look at the data and see is worth for implementing such models is good enough to derive answers from the data. And then if it's good, and we will go and implement, start taking the data preparation. Basically, it involves fixing the mixing records, identifying the incomplete records, and fixing them, and so on, right? And then we will go through the modeling process. We just explain how we will actually do it with SME heuristic sessions, and then identifying the heuristics patterns, and for the test walks patterns and the impact of factors. And then finally we validate and report it. Basically the validations, we will do it with a statistical method, and also we will give it to SMEs to do an eyeballing the recommendations. And then we implement the data lake, REST API interfaces, and pull the data automatically from these repositories to give the live recommendations. And then this live recommendation is fed back to the CI/CD pipeline, where it actually picks up and start executing it. Okay, so this actually gives us a very good benefits. Really solved some of our customers' real challenges. Gets unattended seamless impact analysis and the test selection more prioritization. It gives a very quicker feedback, and we were able to identify the defects much earlier in the cycle, which actually given a very good efficiency of 40%. And the SME heuristic mining session actually brings out this heuristics, and it maintains the SME tribal knowledge within the organization, and it maximizes the benefit of the data, where the data is a new oil. We leverage the advanced technologies like machine learning analytics, where we are actually catching up for the future as well. And we have seen that it actually helped our customers to increase the DevOps speed by 65%. And this can be given, applied for the future use cases like unattended auto heal use cases and so on, right? So since we are running out of time, I thought I'll just quickly flash some of the screens of the interfaces of Impacto. Um, yeah, so that. Yeah, so these are some of the challenges that we typically face while we implementing Impacto with our customers. First thing is the data quality. So this is something that we all of us go back and watch out our data, good our quality data is, that make sure that we store quality data which can be applied for future analytics. And then people do violate the process. They don't really put the right data just for a time release pressure. They need to put some data and then move on. So that's something causing a lot of challenges with respect to data. And then the SME's availability for validation, right? When we come up with the recommendations, they might need to look at eyeball the recommendations and come back their feedback so that this can be the model can be tuned to give better accuracy. I've given the link for the water quality report. It's a good report where you can actually really get good insights about what's happening, how things are, how industry is shaping up with respect to quality. And with that, we are open for question and answers. So while we wait for question and answers, yeah, as I mentioned, like first thing that we need to really do is the mind our data and start implementing simple heuristics, right? So typically how you would do it, try to model them. There are a lot of sources available with Python and R. We can actually quickly learn and then build some of the algorithms. We did talk about a couple of recipes which you can actually do it. Similarly, you have your own heuristics. You can start automating them using the R and Python models. Yeah. Vivek, do you have any questions here? Okay. So we have a question here. So how do we measure the effectiveness of the recommendations? So this is a very good, interesting question. We will actually do that in multiple ways. The number one is the statistical way. For example, let's say you are coming up with the recommendations for test selection. You have 18 months data. What we do is we will use first 12 months data as a kind of training data, and then we try to predict the recommendations for last 6 months, and then we will validate the recommendations with the actual data. Typically, we will use the statistical parameters, measuring parameters like precision recall and F measure, which we will validate the accuracy. And the next method would be like, we will ask the SME to do come up with their own recommendations on the test plan. And then we will kind of compare the recommendations came from the model and also the SME's recommendations. We will see that where there's a gap and try to see that why that's a gap. And then we will actually improve the model accuracy if we are missing any heuristics, which generally the SME applies. And the last method is like, again, we will run this model for some time and then see how it's actually helping. So that's the last method. So any other questions? Okay, if no further questions, I think we are good. Thank you for joining us. And good luck.